Hello everyone. In this video we are going to see the concept that is pulse modulation. What is the difference between an analog modulation or a continuous modulation and a pulse modulation? What is the definition of pulse modulation? What are the types of a pulse modulation? And how to draw the waveforms for the corresponding types of a pulse modulation. Now let's see what is the difference between a continuous modulation and a pulse modulation. So in the continuous modulation or analog modulation, the high frequency signal that is considered is a continuous signal, which means that signal is always continuous with respect to time. It is nothing but an analog signal. Whereas in pulse modulation, the signal is of type a pulse signal. Now what is the advantage of this pulse modulation compared to your analog modulation or a continuous modulation is the power is not continuously carried by your signal in pulse modulation, and also in the predefined intervals you are transmitting your pulse modulated signals through the channel. These are the two advantages of a pulse modulated signals compared to the analog or a continuous modulated signal. Okay, now let us see what is pulse modulation. So the pulse modulation is defined as the characteristic or a signal parameters of a pulse carrier varied in accordance with the instantaneous amplitude of message signal or modulating signal or baseband signal is called as pulse modulation. Now what do you mean by signal parameters? For example, if you consider an analog signal. Now what are the signal parameters of an analog signal? It is amplitude, frequency or a time period, and phase. Similarly, the signal parameters for a pulse carrier is amplitude and time period. So depending on the signal parameters of a pulse carrier, the pulse modulation is divided into two types. First one is a pulse amplitude modulation and second one is pulse time or duration modulation, that is PTM or PDM. Again, this pulse time or duration modulation is divided into two types, that is pulse position modulation PPM and pulse width modulation PWM. Now let's see what is pulse amplitude modulation. It is defined as the amplitude of a carrier pulse is varied in accordance with the instantaneous amplitude of a message signal or a modulating signal or baseband signal is called as pulse amplitude modulation. In this, the message information will be carried in the varying pulses of a PAM signal. So here the width and position of a PAM pulses are constant, and the PAM is divided into two types. They are depend on the message signal polarity. It is again divided into two types, that is single polarity PAM and double polarity PAM, and the second classification is depending on the shape of a top of PAM pulses. It is again divided into two types, that is a natural PAM or flat top PAM. Now let's see what is a single polarity PAM. So single polarity PAM means the message signal is having only positive polarity. In order to obtain a positive polarity signal, a fixed DC voltage level is added to your message signal to ensure that the pulses are positive at all times. If you see from this graph, the message signal is having a positive polarity with the added DC level. Okay, some DC level is added to the message signal to obtain a positive polarity, and this is superimposed with a pulse carrier signal in order to generate a PAM signal. Now how we have drawn this PAM pulse means, consider the time instant of a carrier at this point. So till this point the amplitude of a message is varying. So since it indicates that some signal is present at this point, after at this point from this instant to this instant, the pulse carrier, let us say it is a zero value. Okay, so it's zero value, so 0 into your message signal varying amplitude, so it's at this point its value will be 0. So in this way you are drawing the waveform of a PAM. Now next to see the concept, that is double polarity PAM. Now, what do you mean by double polarity PAM? So, in the double polarity PAM, the message signal is having both positive polarity as well as a negative polarities. Now, let us consider the message signal which is having both positive polarity and a negative polarity, and it is superimposed with the pulse carrier train in order to generate a double polarity PAM signal. How we have drawn this waveform is, this concept is similar to the concept that we have drawn in a single polarity PAM, that is, at this instant of time some pulse amplitude is present, so this is varying with your message. Okay, at this point the pulse amplitude is 0, so 0 into your modulating signal, simply it is 0. We can say that simply by multiplying your message signal with your carrier signal you can generate a PAM signal, whether it may be a single polarity or a double polarity. Now next, see what is a natural PAM. So the pulses having varying top in accordance with the instantaneous amplitude of message signal. So for this PAM signal, these pulses is having a varying top. This is the disadvantage in the communication system. Why? Because the varying amplitude on the top of a pulses will easily affect the noise, or noise is easily affected this varying amplitude of a pulse signals. So through, if you transmit this natural PAM through the channel, there may be a chance that you cannot recover your message signal from the noise, or you cannot separate your noise and message information at the receiver part. Now let us see what is a flat top PAM. So in this, the top of a pulses are flat, thus the pulse is having a constant amplitude within the pulse interval. So this is the flat top pulse. At this point, this top of a pulse is having a constant value, so it is not easily affected by the noise, or a noise effect will be less for this type of signals if you transmit through the channel. Now next is the concept that is pulse width modulation. So now what is the definition of this pulse width modulation? Means the width of a pulse carrier varied in accordance with the instantaneous amplitude of a message signal or a modulating signal or a baseband signal is called as a pulse width modulation. So now the message signal has to be again superimposed with the same carrier signal, that is a pulse carrier train, and has to generate a PWM signal. Now how we have drawn this waveform is, consider that at this instant of time, so at this instant of time, now measure what is the amplitude of a message signal. So at this point the amplitude of a message signal is less, so which means that the width of a first pulse should be less. Now let us see what is the amplitude of this second pulse. At this point the amplitude of this message signal is maximum compared to the previous pulse, or it is greater compared to the previous pulse message signal amplitude. At this point the width of your pulse should be increased compared to your previous pulse. Next, if you consider the third pulse, at this point of instant at this point, the amplitude of a message signal goes on decreasing. Since it is decreasing, whatever the pulses that is present in this instant of time or in this interval, their corresponding widths should be decreased. Okay, now from this point to this point, during this interval, again the message signal amplitude is slow on increasing, so again the width of your pulses should be slowly increased. In this way you are drawing a PWM signal for the given message signal and pulse carrier signal. Now next, see the concept that is a pulse position modulation. The definition is, the position of a pulse carrier varied in accordance with the instantaneous amplitude of a message signal or a modulating signal or a baseband signal is called as pulse position modulation. Here how we have drawn this PPM signal is, first we have to draw the waveform of a PWM. How we have drawn the waveform of a PWM I have explained in the last slide or a previous slide. Okay, now see how to draw the waveform of a PPM signal. So if you observe the PWM signal at this point, so this is your leading edge, nothing but the signal rising from 0 to 1, and this point is a trailing edge. Okay, that is nothing but the signal falling from 1 to 0. Indicate this trailing edge points of a PWM signal. Okay, and this trailing edge points indicates the starting of a PPM signal. So these are the trailing edge points of a PWM signal. So at this point it indicates the starting of a PPM signal. In this way we are going to see how to draw the waveform of a PPM from the PWM. Thank you.